Question 1. Scenario. An analyst wants to detect a spike in failed sign-in attempts by counting failed logons per hour across the last 24 hours, grouped into hourly buckets for a trend chart. The question is, which KQL operators should the analyst use together to produce hourly counts? Your options are: Option A, project and extend only. Option B, summarize count by bin, time generated, 1H. Option C, distinct time generated. Option D, sort by time generated desk. Take a moment to think about your answer. The correct answer is B, summarize count by bin, time generated, 1H. Why B is correct? Summarize count by bin, time generated, 1H, aggregates rows into hourly time buckets and counts events per bucket, which is the standard KQL pattern for building an hourly trend of events like failed sign-ins. Why A is wrong? Project and extend reshape or add columns per row. They do not aggregate counts into time buckets. Why C is wrong? Distinct time generated would return unique timestamps, not hourly aggregated counts of failed logons. Why D is wrong? Sort by time generated desk only orders rows chronologically. It performs no aggregation or bucketing. Question 2. Scenario. An analyst is filtering device process events for command lines that contain the exact substring, invoke mimikatz, and wants the fastest performing filter since the table has hundreds of millions of rows and the term is a fixed literal string, not a regex pattern. The question is, which KQL string operator should the analyst use for best performance in this case? Your options are: Option A, matches regex. Option B, contains _CS with a wildcard on both sides written manually. Option C, has _CS for case sensitive, since it matches whole terms and uses the term index. Option D, starts with only. Take a moment to think about your answer. The correct answer is C, has _CS for case sensitive, since it matches whole terms and uses the term index. Why C is correct? The has operator performs whole term matching against KQL's built-in term index, making it significantly faster than contains or regex for literal term searches, which is why it's recommended whenever matching a full word term rather than a partial substring pattern. Why A is wrong? Matches regex is the most flexible but also the most computationally expensive option, unnecessary for a fixed literal term. Why B is wrong? Contains performs substring matching without using the term index, making it slower than has for whole term searches at scale. Why D is wrong? Starts with would only match command lines beginning with that exact string, missing valid matches where the term appears elsewhere in the line. Question 3. Scenario. An analyst wants to find all devices that have a high severity alert in the alert info table, but do not appear in the device events table for an automated remediation action within the same day. The question is, which KQL join type should the analyst use to find alerts with no matching remediation event? Your options are: Option A, join kind equals left and T. Option B, join kind equals inner. Option C, join kind equals right outer. Option D, union. Take a moment to think about your answer. The correct answer is A, join kind equals left and T. Why A is correct? Join kind equals left and T returns rows from the left table, alert info, that have no matching rows in the right table, which is exactly the pattern needed to find alerts without a corresponding remediation event. Why B is wrong? An inner join returns only rows that match in both tables, which is the opposite of what's needed to find alerts lacking a match. Why C is wrong? A right outer join keeps all rows from the right table, which would surface remediation events, not the unmatched alerts being sought. Why D is wrong? Union simply stacks rows from both tables together without any matching logic. It cannot identify unmatched records. Question 4. Scenario. A custom log table stores a dynamic typed column named additional fields containing JSON like client IP 1.2.3.4, risk level, high, and the analyst needs to filter events where risk level equals high as a normal string comparison. The question is, what should the analyst use to extract and use the risk level value in a where clause? Your options are: Option A, split, additional fields. Option B, strucat, additional fields, risk level. Option C, ago, additional fields. Option D, extend risk level equals toString, additional fields, risk level, then where risk level equals high. Take a moment to think about your answer. The correct answer is D, extend risk level equals toString, additional fields, risk level, then where risk level equals high. Why D is correct? Accessing a property of a dynamic column with dot notation, additional fields, risk level, and converting it with toString, extracts the value as a string, which can then be used in a where clause for exact comparison. Why A is wrong? Split divides a string by a delimiter into an array. It does not pass JSON key value pairs from a dynamic column. Why B is wrong? Strucat concatenates strings together. It does not extract a specific property from a JSON object. Why C is wrong? Ago calculates a datetime offset from the current time. It has no relevance to parsing JSON fields. Question 5. Scenario. An email events derived table has a column named recipient list that stores an array of multiple email addresses per row, one email sent to several recipients, and the analyst needs one row per individual recipient to count how many times each recipient received a flagged email. The question is, which KQL operator should the analyst apply to the array column first? Your options are: Option A, summarize make underscore list, recipient list. Option B, MV expand recipient list. Option C, distinct recipient list. Option D, top 10 by recipient list. Take a moment to think about your answer. The correct answer is B, MV expand recipient list. Why B is correct? MV expand, multi-value expand, takes an array-typed column and expands it so each array element becomes its own row, which is required before the analyst can group and count occurrences per individual recipient. Why A is wrong? Make underscore list aggregates values into an array, the opposite operation of what's needed to flatten an existing array column. Why C is wrong? Distinct recipient list would return unique array combinations, not individual recipient rows suitable for per recipient counting. Why D is wrong? Top 10 by recipient list sorts and limits rows. It does not flatten array values into separate rows. Question 6. Scenario. An analyst wants a single query result row per device, showing a comma-separated list of all distinct process names that ran on that device in the last 24 hours, to spot devices running an unusually large variety of processes. The question is, which KQL aggregation function should the analyst use inside a summarize statement? Your options are: Option A, count. Option B, AVG. Option C, make underscore set, process name. Option D, percentile, process name, 90. Take a moment to think about your answer. The correct answer is C, make underscore set, process name. Why C is correct? Make underscore set aggregates values from multiple rows into a single dynamic array of distinct values per group, which is exactly what's needed to produce one row per device listing its distinct process names. Why A is wrong? Count returns the number of rows per group, not the actual list of distinct process name values. Why B is wrong? AVG computes a numeric average and cannot be applied meaningfully to a string column like process name. Why D is wrong. Percentile calculates a statistical percentile of numeric data. It is not applicable to aggregating a list of string values. Question 7. Scenario. A device generates multiple heartbeat records per hour in a heartbeat-style table, and the analyst needs only the single most recent record per device, based on the latest time generated, to check current device status. The question is, which KQL pattern most efficiently returns the latest row per device? Your options are: Option A, summarize arg_max, time generated by device id. Option B, summarize min, time generated by device id. Option C, sort by device id ASC. Option D, distinct device id. Take a moment to think about your answer. The correct answer is a summarize arg_max, time generated by device id. Why A is correct. Summarize arg_max, time generated by device id returns the full row corresponding to the maximum time generated value for each device id group, efficiently giving the latest record per device in one pass. Why B is wrong. Min, time generated, would return the earliest timestamp per device, the opposite of the most recent record needed. Why C is wrong. Sorting alone does not deduplicate or filter to one row per device. It only orders all rows. Why D is wrong. Distinct device id returns only the unique device identifiers, not the full latest record with all other columns. Question 8. Scenario. An analyst wants to reuse a specific, complex time range and severity filter across 5 different hunting queries during an investigation session, without retyping the same, where, conditions in every query. The question is, what KQL construct should the analyst use to define these reusable values once? Your options are: Option A, a separate workbook per query. Option B, a watchlist. Option C, a materialized view. Option D, a let statement defining variables at the top of the query, reused across query parts. Take a moment to think about your answer. The correct answer is D, a let statement defining variables at the top of the query, reused across query parts. Why D is correct. The let statement allows analysts to define reusable scalar values, datetime ranges, or even tabular expressions once, and reference them multiple times within the query, or across a linked set of queries in the same session, avoiding repetition. Why A is wrong. Creating a separate workbook per query is a heavyweight visualization construct, not a lightweight mechanism for reusing filter values within KQL. Why B is wrong. Watchlists store reference data uploaded to the workspace. They are not the mechanism for defining reusable in-query scalar variables. Why C is wrong. Materialized views pre-compute and store query results for performance. They are unrelated to simply reusing a filter condition across queries. Question 9. Scenario. An analyst has a list of internal CIDR ranges, e.g., 10.0.0.0/8, and needs to filter device network events to find connections where the remote IP falls within one of these internal ranges, rather than doing exact string matching. The question is, which KQL function is designed for this kind of CIDR range comparison? Your options are: Option A, Strollen. Option B, IPv4 is in range. Option C, Tupper. Option D, bin _at. Take a moment to think about your answer. The correct answer is B, IPv4 is in range. Why B is correct. IPv4 is in range. Checks whether a given IPv4 address falls within a specified CIDR range, which is the correct function for matching an IP against ranges like 10.0.0.0/8 rather than exact string equality. Why A is wrong. Strollen, returns the character length of a string and has no ability to evaluate IP address range membership. Why C is wrong. Tupper converts a string to uppercase and is irrelevant to numeric, CIDR-based IP comparisons. Why D is wrong. Bin _ buckets values, often used for time series alignment, and has no role in IP range matching. Question 10. Scenario. An analyst runs a query combining device process events and device network events using a union operator and notices the resulting table has many empty columns because the two source tables have different schemas, making the results hard to read. The question is, what is the best practice to make this union query output cleaner and more useful? Your options are: Option A. Avoid combining different tables entirely and always query one table at a time. Option B. Use join instead, which never produces empty columns. Option C. Use project or extend before the union to select and align only the common, relevant columns from each table, adding a source identifying column. Option D. Ignore the empty columns since they don't affect query correctness. Take a moment to think about your answer. The correct answer is C. Use project or extend before the union to select and align only the common, relevant columns from each table, adding a source identifying column. Why C is correct. Explicitly projecting or extending each table to a consistent, relevant set of columns, and optionally tagging rows with their source table before unioning produces cleaner, more readable results by avoiding the sprawling schema mismatch that raw unions of dissimilar tables create. Why A is wrong. Avoiding combining tables entirely discards a core KQL capability needed for cross-table correlation, which is essential for many hunting scenarios. Why B is wrong. Join is used to match related rows based on a key, not to simply stack results from tables with different schemas, and it also does not eliminate empty, mismatched columns. Why D is wrong. While empty columns don't break query correctness, ignoring them results in cluttered, harder to analyze results, which the analyst is specifically trying to avoid. Quiz complete. You have reviewed all questions and their full explanations. Great work. Please like and subscribe my channel for more such contents.